All right, this is the last question from 8.3. Probably the best question that we've done so far this year. It's the one about paired. Well, you wouldn't know this, but that's not going to be there. That's definitely not going to be there. That's not going to be there. But what I would like is you to take out your calculator and type in that data in your spreadsheet. 2 columns. Pause it. Do it. Good students. All right. Now let's assume we did it. Back that up a little bit. If you hear any singing in the background, that's Joey. He's supposed to be putting himself to bed. Alessandra? I saw your shadow under the door. Go back to your room. Yes. I waited till I was like 36 before I had kids. So, kids. I'm not saying I have all the answers, but that's Twinkle Twinkle Little Star if you're listening. So, I put my data in there. Oh my gosh, we have weight and groove. Seems like 2 variables. It's not. It's 1 variable. So, we're doing confidence interval for the mean difference. Okay. And then it doesn't say anything about weight minus groove, groove minus weight. It doesn't matter. It rarely does, but whatever. I'm making a new variable. You could have just started by subtracting those yourself, but I like to let the calculator do the work. So I'm going to call this new variable DIFF. I must have something named difference already, or else it wouldn't have showed up in black. So let's call it diff E. All right. And then we're going to use this next row, the formula row. So I'm going to say, so it's got the equal sign over there already. It's just like a regular old spreadsheet. I'm going to do weight minus groove. So I'm just going to start typing in weight. W-E-I-G-H-T, turn black because it's already a variable, minus groove. G-R-O-O-V-E. And now it's black. Press enter and it does the calculations for you. This is the variable I'm using. Okay, let's see what we got. 95% confidence interval, mean difference. So I don't have to go back and forth to this too many times. Sample size 16. That's Alessandra singing happy birthday to Joey. We do not know the population standard deviation, so it's going to be T. We're doing 95%. All right, let's do it. And there's Daisy. She'll be barking in no time. Panic step. It says it in the problem. Estimate the mean difference from the 2 methods. Okay. Assumptions. Was it random? Yes. Okay, we always want SRS. Otherwise, it could be just some guy named Billy Bong, picking out random people or tires or whatever. Independent. I don't know how big the company is, but let's assume there's more than 160 tires. I'm going to write it the British style. Tires in this population. Boom. Normal. Well, here's a problem. There's only 16. It doesn't say anywhere in the problem that it came from a normal population. I mean, feel free to take a look, but it doesn't. So 16 is over that 15 threshold, but it's not over the 30 threshold. So we have to look at the graph. Oops. So let's go to the hell. I didn't mean to do that. Let's go to this. And remember, I don't care about weight. I don't care about groove. I care about this diffie. Nice. That doesn't give me any reason to suspect anything. Looks pretty symmetric. Let's look at maybe the box just to make sure there are no outliers. Great. I don't know, normal probability plot just to check. Make sure it's linear. Boom. So, I'm not going to sketch the graph, but I'm going to reference that I looked at it. Dot plot looks relatively symmetric with no outliers, safe to use T procedure. Don't say sampling distribution is approximately normal, because it's not. PAN. Let's use calculator language. T interval 1 sample. Or you could 1 sample T interval if you want it to sound less stupid. Formula X bar plus minus critical T S over square root N. Okay, now I think, did I calculate that stuff yet? I don't think I did. Let's go back one screen, control left, and let's do our calculations. I think you can do a confidence interval from this screen. Don't see why not. So let's go menu, statistics, confidence intervals, T interval, data. Yeah, we got the data this time. I want to use the diffie list. Confidence was 95. And let's put it in column E. Sounds good. Boom. Okay, so we weren't given anything in this problem, so it might be a good idea to write down some numbers. 4.56 was the X bar. this always helps me. Degrees of freedom. For some reason, I always forget to put my degrees of freedom. So seeing it there reminds me. I'm going to mention my degrees of freedom equals 16 minus 1, which is 15. Plus minus the margin of error was 1.71876, whatever, having fun. And then, again, because it's here, I'm going to write the 3.23 right there. I mean, what the heck? Makes it easy. Okay. And my interval is the I step, 2.84, 6.28. And we take it home. I am 95% confident that interval from 2.84 to 6.28 contains true mean difference. Now, this would be a good time to mention how we did it. We did weight minus groove. Doesn't really matter, but it kind of matters. So, true mean difference, weight minus groove in the two methods. All right. Now, 2.84, 6.28. What units is that in? Thousands of miles. Okay. Does your interval in part A give convincing evidence of a difference in the two methods? So, if there was no difference, we've done stuff like this earlier in the year. If two things are the same and you subtract them, as they say in the subcontinent, same. Same minus same, you get 0. Same minus different, you get not 0. All right, well, let's see. We think that the true mean difference is somewhere between 2,000 and 6,000 miles. It doesn't have 0 in it. So, does your interval in part A give convincing evidence of a difference in the two methods? Yeah. If they were the same, 0 would be a logical possible solution. According to this, in our 95% confidence interval, we're not going to get 0 very often, as in never. So to answer part B, ATFQ, does your interval give convincing evidence? Yes. Justify your answer. Since 0 is not within our interval, look like the same piece of paper. That says interval. I believe there is a difference. Boom. That was a fun problem. It was a really good problem.